Hello and welcome everyone to this third webinar of our Coastal Resilience webinar series. This webinar is titled Coastal Connections, Interdisciplinary Methodologies for Resilient Shore. My name is Sara Pasqualetto. I am the Communication Officer of the Decade Collaborative Center for Coastal Resilience. And this, as I said, is the third of a series of webinars that has been organized by the Decade Collaborative Center for Coastal Resilience together with CMCC, Foundation Euro-Mediterranean Center on Climate Change. So just briefly to illustrate to you, you probably have seen this agenda, but just to remind you what today is going to be about. So there will be a brief introduction by me right now to introduce to you the DCC as well as CMCC. We will then follow a slightly different format than usual, as Megnaa and Andrea, our guests for today, will dive into a real dialogue and present their approaches to study coastal resilience in different contexts. And they will ask themselves also what the strengths and the pitfalls of these two approaches are. We will then have a Q&A session followed by a wrap-up moment. As always, just some indications on what you can do and how this webinar will work. So this webinar is being recorded and will be made available on our YouTube channels. If you have any question, you should see a Q&A box on the bottom of your screen. So please use that. And when relevant, please also address your question to one of the speakers. That will make it easier for us to address the question to the right person and they can see it and answer to you. This presentation will also be made available on the events page on our website. You will find a QR code to access that directly later in the slides. Okay, so the DCCCR is a UN Ocean Decade action. So we are part of this great galaxy that is the UN Ocean Decade, and we are one of the centers that are part of the decentralized coordination structure of the Ocean Decade. So our main mission is to strengthen the connection between new science and technology that is developed within the Ocean Decade with coastal stakeholders, implementing innovative co-design practices for coastal resilience. We do so by also helping and catalyzing new Ocean Decade actions. For example, we organize outreach activities like these webinars. We're mobilizing resources, and in general, we just try to coordinate actions and projects to advance the mission of our center as well as the Ocean Decade. Our activities are structured in four main pillars, four strategic objectives. By the end of the decade, we would like to improve science information for all, enhance stakeholder engagement for coastal areas. We would like to promote equitable education as well as upholding environmental justice for coastal communities. On top of this, we're also involved in other activities which are spearheaded by other organizations. We, for example, have identified a gap in the representation of actions and communities from the Global South. And so we are trying to promote inclusion of diverse and representative perspectives through a Global South Coast approach. We are managing the community of practice on coastal ecosystems and community resilience, which I believe some of you may be a part of. We're also involved in an informal working group on that is called Cities with the Ocean. It's promoted by the Decade Coordination Unit to bring the ocean science produced by the Ocean Decade to urban communities at their service to develop their sustainable future. We're also supporting the development of the Global Coast Experiment, which is led by the Coast Predict program. And finally, we're also contributing to the Vision 2030 process, which is a strategic ambition setting process that will help identify the goals for the Ocean Decade. So some of the appointments that are coming up from our side. So on the 12th of December, we will have a workshop, which is titled Sharing Best Practices in the Sustainable Management of Coastal Environments. On the 20th of February, if you're attending the Ocean Sciences meeting in New Orleans 2024, please know that we also have a town hall. It's titled A Dialogue on Coastal Cities and Coastal Community Resilience. So please think about joining us for that. And then the big event next year will be the Ocean Decade Conference in Barcelona. We have submitted two proposals for two satellite events. One is titled Coastal Coastal Resilience Symposium, and the other one is From Senegalese Coast to Global Horizons, documenting climate change impacts on fishing communities. All these and more events are available on our website on this page. There are different ways you can get in touch with us. We have a dedicated page on different ways that you can engage with the DCC as well as the Ocean Decade. You can scan this QR code if you want to access that page. The easiest way to get involved and to be updated on our activities, our future events, is by subscribing to our newsletter. And I would also recommend following us on YouTube on our channel. This is where we will also upload the recording of this, and our previous webinars are already there. Also, very briefly about CMCC, who has co-organized this webinar series with us. CMCC is a research institute based here in Italy, whose mission is to investigate and model our climate system and its interaction with society to provide reliable, rigorous, and timely scientific results to stimulate sustainable growth, protect the environment, and develop science-driven adaptation and mitigation policies in a changing climate. They also develop foresights and quantitative analysis for the future planet and society. They are organizing many events, many exciting opportunities to get involved with them. I would recommend you follow them. The handle is always at CMCC Climate that you see here. You can find CMCC in all of these platforms. So please make sure you follow them and to stay updated on their events and their activities. Okay, so I was very quick. I'm really happy I did not waste too much time. And so we will dive now into this, the core of our webinar, which is this dialogue, as I mentioned. So we will follow a different approach. We will not have two different presentations on Andrea's and Megnaa's projects, but they will provide you with some information on two different case studies that they are researching on and they are working on. They will also present to you their personal approaches. So Megnaa is an anthropologist, whereas Andrea is a modeler. So two different ways to look at coast and study coastal resilience. And they will also look at each other's perspective and see what are the strengths and the, let's say, less strong points of each other's discipline. So without further ado, I would leave the floor to Andrea to introduce to you this talk. Andrea, please.
Thank you, Sara. Hello, everyone. So I'm Andrea Ficchì, Senior Postdoctoral Research Fellow at Politecnico di Milano in the Environmental Intelligence Lab. And I'm one of the AXA Research Fund fellows funded under the joint call with UNESCO, IOC, Intergovernmental Oceanographic Commission, to respond to the challenges of the Ocean Decade, and so to improve the resilience of coastal communities around the world. And so I will start with a brief context. As all of you know, climate change is increasing the risk of flooding in coastal communities, and this is due to several drivers, including sea level rise, but also episodic extreme events that are becoming more intense and more extreme, as for example, tropical cyclones that affect with flooding, extreme rainfall and extreme winds coastal areas. And due to sea level rise, we can estimate the population at risk as it has been done by several scientists, and as it has been summarized in one of the latest IPCC reports here in the map. You can see the projected number of people at risk due to sea level rise and for extreme coastal flood events. So an extreme event that can occur with a likelihood of 100 every year, so a 100-year return period event, as we say in modeling. And here in this map, you can see that there is represented the number of people at risk with the size of the circles that represent additional people at risk per IPCC region compared to the current number of people at risk. And on the right, the circles on the right show the share of people with respect to the current region's population, while on the circles on the left show the absolute numbers of millions of people at risk under an intermediate greenhouse gas emission scenarios. And so a likely scenario. And these estimates are then reported with different colors that show actually also the timing of the risk increase exceedance, let's say, based on different time frames, and so up to 2150 for the century ahead. And we can see that there is a consistent increase in all regions in the world of flood risk and exposure, but with large differences globally. And some regions in particular, they will see an increase in exposure that will happen at a higher rate than other regions, as for example, in Southeast Asia, South Asia, and in Africa, where 5 million additional people will be at risk in the coming few decades, and also then other regions, as for example, northwestern Europe, they will see a very large increase, but with more time to adapt to this increase in exposure. And so adaptation is very important, as we can see in the next slide, where I summarized a few points from my modeling point of view. So we can rely also on short-term solutions that often can help communities, as for example, emergency plans, humanitarian actions, or insurance to increase the resilience of coastal communities. And these solutions often rely on forecasts and predictions that are based on mathematical models, often physically based, but also increasingly data-driven and machine learning models. And also they rely on projections, especially for planning in the long term. And these can inform also, of course, a longer term, longer path adaptation solution, as for example, increasing the protection of coastal areas with either hard infrastructures, protections, but also nature-based solutions. And however, recent studies, as the one reported in the slide by Megnaa et al., they show that the current global coastal adaptations falls short, and it's still far from attaining the complete adaptation potential. And this is also due to the current limitations of state-of-the-art models, as for example, flood forecasting models and climate services that still have important limitations that need to be let's say, solved and tackled in as soon as possible. And in our research of modelers, there is a great effort in my community to continue the progress of this model that has been huge in the past decades already.
Thank you, Sarah and Andrea. So I'm actually an anthropologist. My name is Megnaa Mehtta, and I'm a lecturer in social anthropology at UCL. And my work is based out of the Bay of Bengal Delta. And I actually, for the AXA fellowship, will be working both in the West Bengal and Bangladesh side of the Delta. And as Andrea mentioned, some parts of the world, but specifically some communities will face a higher and heightened exposure, and sometimes vulnerabilities and communities that face these hazards. It depends on the extent of vulnerabilities, like in these regions where I've done long-term field work. And so I just want to sort of mention from the outset that I am not an expert on floods particularly, but the region where I've conducted long-term fieldwork and will continue to do research is prone to flooding and has been endemic to cyclones and storm surges. And so what Andrea and I, thanks to Sarah and thanks to this opportunity of DCC and this Coastal Connections webinar, decided that we'd have an experiment in really thinking about what it means to look at floods from two different disciplines. And we might end up at the end of this webinar with really questions for each other that we can't answer, but this is an exercise that we both haven't, of course, done before, but one that we hope to learn a lot from. And so the way that we're going to structure is that I'm going to give you, just for about 4 or 5 minutes, a brief introduction to my field site and the area where I have done long-term field work. And then Andrea will take you to Mozambique, which is where his models and his modeling perspective has been embedded. And then we'll try and tell you both a little bit about our disciplines and then open it up for questions further. So the social history of the Bengal Delta is one where, and again, as an anthropologist, it's really important to know that this is a region which has been endemic to displacement as well. So the Bengal Delta, which is, today is part of Bangladesh, part of West Bengal, and it's formed by 3 large rivers, has also had a history of very long-term ecological refugees through displacements and also movements because of prior floods and cyclones, but also political upheavals. So there was a partition of India and the creation of Bangladesh that led to what is, in human history, one of the largest mass exoduses in human history across the borders. So today in all of the Bengal Delta, 7.2 million inhabitants live in this region. And there is, to large extent, still lacks very basic infrastructure such as healthcare. So there aren't that many fully functioning hospitals and roads. And at the time that I was doing long-term field work, on islands that border the Sundarbans, which is the world's largest mangrove forest, there was no electricity on these islands. And the communities on the West Bengal side belong to lower caste Hindu groups known formally as untouchables in India. And today in India, the government nomenclature would be scheduled castes. There's also diversity of groups which belong. They're Muslims, Adivasis. The majority are landless communities, but otherwise with very small land holdings, and they're paddy cultivators. One of the most important histories of this region in terms of its ecological history is that these were embanked islands, so they were reclaimed with embankments. These are mud sort of buns that then stopped salt water from entering into these areas for sweetwater paddy cultivation. And so any surges of saline water or breaches in embankments create loss of crops and damage to property. And what is very fascinating about the ecological history of the delta is that these rivers that form this delta, the Megnaa, the Brahmaputra, and the Ganges or the Ganga, carry about 1.4 billion tons of silt every year. And these rivers, of course, have been dammed. So there have been many anthropogenic forces which have allowed for or actually prevented fresh water from coming from these rivers into the delta, which has been actually a cause of kind of the degradation that is taking place with the mangrove loss. It is today a conservation hotspot with the diversity of flora and fauna because of this brackish water dynamic of freshwater flow and meeting salt water. It is the only place in the world home to the Bengal tiger that lives in a mangrove forest. So it is for many reasons a global biodiversity hotspot, but also home to a flagship species of a unique sort where there is no other place in the world where a tiger lives in a mangrove swamp, and both sort of amphibious. It has strong monsoons, heavy rainfall, and what's very crucial is, as a result, it has also always been endemic to cyclones and floods. So before the kind of current climate emergency era, the Bengal Delta has witnessed severe flooding, has witnessed floods which have actually been quite productive for the region as well, and I'll get to that in a moment. But this is a region, again, as Andrea pointed out, there are some parts of the world which are prone to higher sea level rise than the global average, and this is one of them, with low-lying deltas and low-lying islands. And so just moving on, the history of floods is, of course, in the past decade or so, there have been major cyclones and super cyclones in this region. And I'm just pointing out to you a photograph, a very recent photograph from Amphan this is Cyclone Yas in 2021, which intersected with the global pandemic. And here are communities that are physically, as you can see, holding on to this mud embankment that I was referring to earlier. So this is the mud that prevents brackish water, a kind of a polder, which is called on the Bangladesh side, or a dike, Dutch dike, but this is prevents brackish water from coming in, and communities with their bodies on the line are preventing brackish water from trying to enter, and so they're hoping for not a breach of this embankment, which did indeed breach. But these cyclones are bound to increase in intensity and their erratic nature as well. But actually, there's been a history of cyclones in the Bengal Delta, and very famously so. This is a recent book by Benjamin Kingsbury, The Imperial Disaster, the Cyclone of 1876. There have been many cyclones, but the reason why I highlight this book in particular is because the book argues that often these events are thought of as natural disasters, and the book turns that interpretation on its head and shows that the cyclone of 1876, and in fact many cyclones like this, are not simply natural events, and I quote, but one shaped by all too human patterns of exploitation and inequality, by divisions within Bengali society and the enormous disparities of political and economic power that characterize British rule on the subcontinent. So again, as an anthropologist, the history of mismanagement in this region and the cholera epidemic that broke out after this particular cyclone and the famine that broke out is what killed many more people than the cyclone itself. So the aftershock of a disaster is something that is often almost as crucial to understand and to study. A very recent book on the Bengal Delta that I want to refer to in the next slide actually is a book by Camelia Devan called Misreading the Bengal Delta. And she argues that we need to disaggregate the way we look at floods and the way we think about floods, because floods have historically, as I've mentioned, been a part of this landscape, and floods have actually in some ways provided vitality and have provided the kind of cultivation of crops. It of course depends on what kind of floods, the intensity of floods, the time of year of the floods. But in the past decade or 2 decades, international NGOs and development experts in this kind of era of climate emergency have begun to view all floods solely caused by climate change and as being detrimental. And recent scholarship like that of Camelia Devan and others have shown the nuances of floods and reveal, in fact, that we need to disaggregate and not have a climate reductive view of flooding. And in fact, if we understand the ways in which communities that live alongside these areas, then we can have their perspectives on flooding. And so I'll leave it to that, and over to Andrea for the Mozambican perspective.
Thank you, Megnaa. And coming to the Mozambique case study, so we see similar problems and challenges in Mozambique to the ones that Megnaa has highlighted, as also Mozambique is one of the areas that sees the highest, Mozambique and Southern Africa more generally, are some of the areas that see the highest increase in sea level rise in projections as the areas in South Asia that Megnaa introduced. And sea level rise is compounded also by here as well cyclones that make regularly their way to Southern Africa, and in particular to Madagascar and then Mozambique. And tropical cyclones are quite frequent, as we see from the statistics. For example, since 1980, about 20 tropical systems have impacted Mozambique, affecting millions of people, causing displacements of hundreds of thousands of people, often at once in a single event, and causing in total more than 2,000 fatalities. As, for example, in particular, we had a large share of these fatalities during one of these cyclones in 2019, that is Tropical Cyclone Idai, and you see some images of the hazard and the impacts on the ground of these cyclones. On the left, the satellite image of Tropical Cyclone Idai approaching Mozambique in March 2019, and then the impacts on the ground on the right with the flooded town of Buzi, and then the flood extent at the regional scale, where you can see in red the flooded area with a composite analysis of satellite images, and this red area covers the size of the country of Luxembourg, to give you an idea of the size of the flooded area. And so these events have huge impacts that include not only fatalities, but of course destroyed homes for multiple hazards, not only high waters, but also winds, crops losses that are often due to submerged fields. And here you have also the tides, and in coastal areas, we have also the impact of salt water. And also epidemics outbreaks are very frequent after cyclone floods, as for example, cholera, and these epidemics affect thousands of people, and of course add compound risks. And so to summarize the challenges here is that we are lacking also sufficient protection infrastructures as barriers and embankments. And from a first discussion with Megnaa, we have here less of such structures than in South Asia. And also another point is that also because of development challenges, homes are very exposed and vulnerable to floods. And we are lacking also cyclone shelters, which are more frequent to find in environments like in South Asia and Bangladesh. So these challenges are then also compounded with technical challenges from the modeling and forecasting point of view. As for example, we see in the next slide, where I summarize the fact that there are national mandated agencies that are doing a great amount of work to increase the local capacities and build local models, both from the meteorological hazards up to the flood risk forecasting, but still global models are also necessary to complement the local information, in particular, for example, to have longer range forecast or also probabilistic estimates of the risk. And these forecasts often come from regional centers. For example, the regionalized specialized center for cyclones here is the Center of Météo France La Réunion, and also from global centers and institutions, as for example ECNWF, the European Center for Medium Range Weather Forecast. And here in the slide you see an example of such forecast for tropical cyclone tracks of Tropical Cyclone Idai on 10 March, where you see an ensemble of tracks and predicted let's say strike areas of the cyclone on the coast. And so we need then a chain of models to transform these meteorological risk into flood risk and flood extent estimates, as for example in a previous project that I worked on at the University of Reading in collaboration with the University of Bristol and ECNWF. We have built a chain where from the of these global models, we complemented this with high resolution inundation maps, and so we were able to then connect global flood hazard forecasts from the global flood awareness system that is represented in the central image to local impacts on the ground, as you can see in the flood map from the University of Bristol's model, where you can see in purple the areas at risk, and also the population exposed in different colors from orange to red, but also the critical infrastructure at risk. So this is the key information. And there are, as I was saying earlier, there are limitations of these models to accurately estimate and predict these impacts on the ground. And for example, for coastal areas, I would say that one of the main limitations is the combination of riverine and coastal flooding in accurate compound flood predictions, as was highlighted also in the literature that is cited here. And these challenges are some of the challenges that I will talk about more in the next part of the presentation, dealing with my modeling perspective to solve these challenges and advance models. And now I will leave the floor again to Megnaa.
Thank you, Andrea. So I'm going to just very briefly, for those of you who might not be familiar, but many of you probably are, just give you what an anthropologist's perspective might be on trying to understand something like floods. And so anthropologists, as you might know, live in a particular field site for an extended period of time. We conduct interviews, household surveys, migration histories, life histories, biographies. In addition to that, we understand everyday life. And as I've mentioned, and I'll give a few examples, history is crucial, both in understanding the present crisis, but also excavating solutions for the future. The attempt is also often to foreground lived experiences and lived knowledge. This is not sort of trying to create a dichotomy between, say, indigenous local knowledge versus scientific expertise, but to be able to realize that both are sort of symbiotic and quite important for one another. And as I've, again said, context of all sorts, the social, the ecological, and the historical very much matters, and as how an anthropologist might go about trying to understand floods. And so I'll just briefly, the next slide, please. I'll just briefly, again reiterate that some of the disasters that we think of as natural disasters are often human-induced. And one of the things that an anthropologist in a coastline might look at is the different hierarchies, not just of knowledge systems, but also hierarchies within the geographies. And so the next slide is just to foreground that the perspectives of people living on these coastal communities can often be disregarded, and for experts or technocrats. And I did introduce embankments earlier. I'm again not an expert. It's hotly debated whether embankments should be here, not be here. Communities find them a lifeline, but they were also imposed at a particular time, and then have made communities dependent on them is one argument. And so a floodplain could have been a better way of thinking about it. But I think citizen science is an exciting way forward. There are many challenges to embankments today in the Bengal Delta. There are concrete embankments being built in these areas. And in the next slide, I just want to show you what it means to be on the wrong side of the embankment. So this on the right, as you can see, is a concrete embankment that was built while I was in the field in about 2016, 2017. And all of the homes of communities that are some of the poorest, which is the most landless, or those who don't own land, live on the very edges of the island. And because they don't have a title of their land, they actually have been rendered on the wrong side of the embankment. So actually they should be behind, so they should be behind the embankment, but in fact the village is behind the embankment, and their homes are even closer to the ocean, to the water, to the river. And so this is, in some ways, not just the local perceptions of risk and vulnerability and protection that anthropologists try to attempt to understand, but also trying to look at and try to map at a very different scale than what Andrea is able to do. But land ownership, who has land, who is dispossessed, who is landless, who's landed, even the geography of poverty within an island, and understanding of material conditions, which then of course impact, who is most impacted by a flood, who will be able to cope with the flood better, very much depends on these material conditions. So if you're going to be rendered on the wrong side of the embankment from the beginning of it, once again, the importance of value systems are key. And as anthropologists, as I've said, we disaggregate information based on caste, on race, on class, gender, and disability. And this is all crucial in moments of disasters and planning for disasters, because not all disasters are experienced or felt equally even in the same community. And the last I would like to emphasize is the importance of power and politics throughout understanding local communities. So this is an image from after Cyclone Amphan of food being given out, which is a super cyclone that hit in 2020, and who gets relief for how long and from whom are again very politically motivated. So if you belong to certain political parties, you'll get compensation if your house was brought down and you won't otherwise. And so ideas of governance are central to a social science perspective and need to be understood from a community level. And so I'll leave it to that as just a way of highlighting the questions that anthropologists like to ask or like to prod. And at a later stage, at a third stage, I think Andrea and I will try and ask each other these questions about the different field sites that we both work in. And as I said, we might not have answers, but it's always useful to pose the questions. So over to you, Andrea.
Thank you, Megnaa. And so I will dive into more details of my modeling perspective. As I mentioned earlier, as modelers, we often have a chain of models that are used to estimate and to predict flood risk and exposure. And here you can see an example or a schematic example of a flood modeling, or I would call it service chain, because we are here not only to model, but to provide information for a purpose. So that is some colleagues would call this more a service, and I would agree with them. And so here you have an example of this chain with for global models. So we are talking about large scale predictions, and these, as I mentioned, they are made by large national centers because there is a need of huge computational resources and infrastructures, and so the union of let's say forces and resources from different countries is key in this type of services. So the first ingredient for this chain is input observations from satellite, but also ground gauges, and then this is combined with hydrometeorological initial conditions that come from both observations, but also reanalysis that are produced by models that consistently in space and time reproduce the state of the meteorological system, the global meteorological conditions. And then these are used as inputs, as I was saying, for driving a numerical weather prediction model that provides now the state of the art is to provide ensemble probabilistic predictions, so a number of trajectories of the evolution of the in the upcoming days and weeks. And for extreme events here, we are focusing, I would specify on sub-seasonal and extended range, as we call it. So we're talking about weeks. And so for large extreme events as tropical cyclone, we have predictability, especially in the first week. And so that's where I will mostly focus in my work. And for a dynamic, then for running dynamic flood hazard model, we need these meteorological inputs and a numerical model that representation of the land surface that is often a distributed model, so that represents the process at the grid scale. And so then it provides distributed outputs that can be translated into maps of, for example, both river levels, but also water levels along the coast. And so we have also a hydrodynamic component of this model for reproducing then levels, and also to translate these into flood extent and water depths on the ground. And so here we have, as I said, a chain of models that then ends with a number of post-processing tools and analysis that is followed to translate these numerical prediction, these gridded outputs into flood impact estimates. This last ingredient is key, as also when we talk about interdisciplinarity, often if we stop at the flood hazard level and the water levels, it's difficult to translate these into interdisciplinary work, because often the question that come in the next slides will be related to the flood extent. And so I here summarize some of the questions that we try to answer. Most often, these are the most frequently questions for us, for modelers. These examples as, for example, what type of flood processes to represent. And so if we are in a coastal area and we want to represent both riverine and coastal and compound floods, we might need to use either multiple model or also compound flood models as newly developed models, for example, by Deltares. And so the choice of models is a big step, is a big first question, because there are many ready-to-use models, simulation and forecasting models. So then we can ask ourselves and to our teams that often should be interdisciplinary, what type of model we need, and what resolution, what frequency for predictions, but also other questions, as for example, going more towards the verification. So is the model providing results that are in a good agreement with observations, and what level of accuracy do we need? Do we need to post-process and to try to improve the model outputs, and also what level of model efficiency is needed? And these are just some examples, of course, but I try to summarize my main questions that come to talk about starting a flood risk work. And then moving towards interdisciplinary work, we need to focus on the flood impacts on the ground, as I said. So what type of flood impacts we need to model? And so if we need to model, for example, impacts on crops, we might be very careful in also understanding if we are focusing on coastal salty floodwaters or on, for example, riverine not salty water, and the impact is different. Then also which communities are affected, if the question is also at which scale, and so these can guide the choice of the model, but also the choice of the resolution. And here there is a big limitation, of course, especially for global models, because they are often run at a larger resolution than local models. But also we have then limitations with data available, so what data is available, and then how human influence and interventions are considered in the models. And often in global models, we have very high-level simplifications of how dams and diversions in rivers, and also how the withdrawals from, let's say, rivers and delta areas are modeled. So these limitations affect, of course, the water levels and following impacts that are estimated by models. And so other questions can be how we can improve the accuracy of these predictions, and how we can improve the value, and what level of value is needed. And also then moving more towards the use of the forecasts, how these forecasts and the predictions are communicated. So these are clearly interdisciplinary questions that many colleagues are trying to answer. And these are also behind the pillars of the current... Sorry, I had a problem. So this is also behind the pillars of the current early warning for all initiative by WMO. And so in the next slide, we can see here how from the literature review, I would summarize the main limitations of global, coastal, but also riverine and compound flood models, as there is a lack of verification, especially for impacts, and often the verification is done based on sparse gauges, but also based on temporally sparse satellite images. And so then we need more focus on impacts, also more focusing on data collection and evaluation of model with different sources of data. And then also there is a lack of integration with inundation and impacts, as this field is rapidly growing, but still models are often a bit disconnected from the hazard part to the impact part. And then we need more compound flood modeling, as I already mentioned. And so these three gaps are three gaps I'm focusing on in my AXA fellowship, especially for the first one and also the third one. So user-oriented impact-based verification driven by decision-making needs, and I will give an example in the next slide. And also then improve the integration of these models, but also focus more on the impacts, thanks also to machine learning enhancements of these models. And so here you have a schematic of how I'm tackling these challenges, as the first block on the left is that we are evaluating state-of-the-art flood services and different types of variables and predictions, and then use these analyses to drive artificial intelligence enhancements of these models via deep learning and machine learning algorithms, driven by the user criteria and objectives, and in particular focusing on two applications, humanitarian emergency action and also insurance plans to, let's say, scale up resilience also by offering index-based insurance plans to farmers in vulnerable areas. And especially in Mozambique, as I mentioned, is my case study. And in the next slide, we can see an example, as I mentioned, of an action-based evaluation that we have been doing with, in collaboration with the CLINT project team. The Climate Intelligence Project is a 4-year European H2020 project focusing on different extremes. And here, in particular, this is of relevance for both projects, as we have focused on tropical cyclones, extreme events, in particular extreme rainfall. Rainfall that is one of the main drivers of flooding. And here we have focused on the needs of humanitarians in Mozambique, as summarized in this slide by the cover of the Early Action Protocol for Tropical Cyclone in Mozambique, where humanitarians focus on forecast up to 3 days so far because of the current levels of error, that is approximately 240 kilometers at 3 days. And so we need to improve the scale of accuracy, let's say the scale at which we can rely on model outputs. And for this, we have developed a framework where we can evaluate these forecasts based on their need of being more accurate, or accurate enough to take actions within, let's say, a box of 200 kilometers. And here you see the two metrics that we focused on, and in particular here I will show you an example of result for false alarms. That is a metric of interest for decision makers. And so if we focus an analysis, as seen in the next slide, based on physically based metrics, for example, the intensity of a peak, this is difficult to translate into interdisciplinary questions and also to information for action for decision makers, as we are just saying, okay, with, for example, with a machine learning enhancement that is depicted by the line with the plus symbol, with respect to the original state-of-the-art forecast by CWF, we improve the mean square error of rainfall intensity. But then how can we use this information for decision-making, and is this information useful? And the answer is probably no. So we need to evaluate models with action-based metrics. And so the next step is then that we have done is to evaluate, as you can see in this animation now, evaluate the same forecast and the same enhancement, but based on metrics that are tailored to the use of humanitarians. And here, for example, the false alarm score has been adjusted so that we can take into account this action scale of their plans of 200 kilometers. And here you can see that we managed to say that, okay, we significantly improve the predictions at 3 days ahead based on their criteria and their needs. And so possibly, you know, machine learning post-processing in this case can be useful to take a better and more appropriate and say more sustainable actions, and this can inform their plans. their multidisciplinary plans. And so I will leave the floor now to Megnaa for a dialogue. Actually, we do this part together, so I will kickstart this part. Sorry. So here we have started to discuss, the two of us, a list of questions that we would pose to each other now for our 2 case studies, but also more generally when we are trying to bridge the gaps between our disciplines. And so my 3 questions to Megnaa were, so how we deal with scalability issues, because, anthropologists and social scientists tell us that we need to focus more on the communities and the description of the risk profile and also inequalities, as Megnaa has highlighted, behind the risk. But so these data are often at a level and scale that is much different and is more localized than what we are used to as modelers. So there is a big challenge on how to integrate this perspective into model-based analysis. And then a second point is how can we reduce social complexities to inform decisions, because often the picture that our colleagues, anthropologists and social scientists give is very complex, as Megnaa said. And so the inclusion of, for example, the different levels of vulnerabilities based on gender and caste, but also different social aspects is very complex into our models. And again, it requires also high resolution level of analysis and model outputs. Then also, what is anthropology unavailable to achieve? So are we missing out something, and what should we focus more on together? And I would leave the floor to Megnaa for her questions, and then we can start the discussion on these points.
Thank you, Andrea. I suppose the short answer to your question is that we need to work together and have interdisciplinary teams. And I think it's amazing to see your perspective as well, because you're absolutely right. Anthropologists, and I don't want to speak on behalf of a very large community of anthropologists, but I think most anthropologists might agree that we probably do not have the kind of data that is required for models. And so scalability is an issue. But instead of trying to speak on behalf of most anthropologists, I'll try and just say that maybe the aspiration isn't to scale up for an anthropologist. And so the aspiration maybe is to get granular. It isn't to say that, I mean, if we get a very, very huge grant, we can have many anthropologists with many research assistants spread across coastlines, getting this granular data. So sometimes it's not impossible, of course, to collect. Economists do that, and you have censuses. You have very granular data in the census, in fact. So it's not as if necessarily, yes, a sole anthropologist. I mean, I'm able to do 300, maybe 500 household surveys with a lot of depth, but obviously on my own, I probably can't do the way in which you've given us. You're talking about Mozambique's coastline. I think that's, and even as I was talking about the Bengal Delta, often I was also giving very specific examples of households and caste communities and women and particular vulnerable groups. And so I guess one way to say is that how, it's a very good question. How does one reduce social complexity to inform decision making? I think my answer to that question is also, how can decision making, it's to turn the question on its head, how can decision making include social complexity more? So perhaps if there was a way in which social complexity could be incorporated into models, I would throw it back to you, because of course the reality on the ground, and maybe correct me if I'm wrong, but maybe we can have the best model, but if local government and the levers of power on the ground is what decides how communities will either get relief or get the house or the cyclone shelter or not, then how does that social complexity ends up mattering in how lives are either saved or are killed. I think anthropology is unable to achieve a lot, of course, in that I think we would probably be very bad bureaucrats or government officials or like decision makers in a flood scenario, because we would probably be like, oh, it's so complicated that we'd have to kind of think about all of the variables, and we probably need modelers to come in and say, okay, this is but at the same time, I do think that especially in the kinds of regions that both of us are looking at, that vulnerability of the groups that again I had some images and photographs of, but how does one actually end up having anthropology or social science perspectives or history influence modelers in ways, and again, I think I'm going to ask you these questions, but I don't have an answer to them, but I'm going to ask you, how is it then, and this is question 4, how does the sort of human component, but also not just the human component, because of course within the human it's quite disaggregated, but how does the non-human component enter into models? How do flora, fauna, sacred landscapes, heritage, monuments, things that are destroyed in floods, or that floods would or we would hope to protect as a community or conserve? So how does models, how do models, or are models taking that into consideration? How do models take into consideration the histories of colonialism, but also the histories of floods in the past? Is something that is the data. I mean, again, this is something, I'm sure there's dynamic data sets that you're constantly working with, but it seems there are changes in the natural landscape, there are changes in the human landscapes, and is there ways in which models can incorporate that? So I guess the last question again to you, what do models miss out? Can models become can integrate a little bit of the granularity of anthropology, or are we in different sections of our disciplines, and basically can we bring these perspectives together? So yeah, I'll leave it to you again.
Thank you, Megnaa. I will try to quickly summarize my perspective on this, which are very difficult questions, of course, to answer. But regarding the human component, but also heritage, as you summarized here, there is a challenge here, and also because we lack, for example, data on decision making, on, for example, behavior of operators for infrastructures, dams, etc., to model accurately these often at a large scale, and also for transboundary basins and systems. So this is a large challenge. And when it comes to history in landscapes, more like let's say at the nexus between also human component but also environmental component, this is another challenge, especially because models are often calibrated at a given point in time, and then human, but also the natural landscape changes, and so the model should be recalibrated, reassessed again continuously. So for example, this regards to your case study where like the sediments load in the delta areas is huge, where you should recalibrate based on the changed morphology. And this also impacts many coastlines where the morphology is also dynamically changing because of extreme events. So this is a large challenge. And then how to translate and consider natural and human components, as you said, in model analysis. So one way that we are dealing with in our lab, for example, Environmental Intelligence Lab at Politecnico di Milano, is to consider these into indicators. And this is there is a large community working on optimizing so the use of resources, but also the management of infrastructures based on a multi-objective, let's say, framework where we consider not only human objectives as, for example, irrigation and like economical activities, but also environmental systems. And we summarize these into simple indicators. That is probably one of the problems, because then this complexity is summarized into one equation. And sometimes it works, but sometimes the complexity and also the spatial distribution of these indicators is requires a level of model resolution and model accuracy that we do not have yet. And so here I think I replied a little bit as well to the last point. So we are lacking again localized high resolution accurate estimates from model for sure, and we lack also the data often to do this, especially in vulnerable developing countries. So there is more work needed on all these aspects, and luckily there is a lot of attention on these, as for example the WMO initiatives, not only the early warning for all initiative, but also to increase the observation network, especially in developing countries. But okay, there is still we have made a long way, but there is still a long way to go on this. And I would leave now the floor to the audience for other questions and more discussion.
Thank you both so much for this very interesting dialogue. I think you both raised very nice and very important questions to each other. And the hope I personally have for this webinar is also that these questions serve as a takeaway for our audience to implement them and keep thinking about it and keep having them as like a reference point to develop more interdisciplinary work in their own labs, with their own groups. I know that we have a couple of questions and comments. So Rusila doesn't have a question, but thought that the anthropology part could inform the dissemination of relief supplies with respects to the more vulnerable. Megnaa, what do you think? Also, I know we're a bit over time, but I also know that we have a couple of takeaways and questions. So I would just ask you to be very, very brief so that we can get everything and still get the chance to just have a wrap up at the end. Please, Megnaa, if you want.
Very quickly, yes, thank you. I mean, anthropologists usually study the dynamics of power and local government, so we can, explain why certain groups are not getting the relief that they should get, but we don't necessarily intervene in them being able to finally get it. I wish we could actually make that happen, but I think it's valuable to know why, who, and when, and how that happens. And so, yes, that is a perspective that anthropologists can definitely highlight and do often expose vis-a-vis the distribution of aid in many contexts, earthquakes and floods and different hazards.
Thank you, Megnaa. And I think we have a question for Andrea from Christine. Do the dynamic flood models include coastal erosion?
Thank you for the question. Yes, the answer is there are some models that include these, and there are some, for example, 2 examples from global institutions include Delta ARES with their, for example, Delft 3D high resolution model, or also the least cost modeling tool from the European Commission Joint Research Center that can model coastal erosion and the interaction with water levels and changes in the sediments and removals of rocks, etc. But this is very difficult, as I said, to calibrate because also of the lack of data. So if we focus on modeling at the larger resolution and global to regional scales, I would say that we have basically a big limitation there as well. that is probably, for example, one limitation that I personally will not be able to assess properly in my modeling work, because also, as Megnaa said, we need a large team effort and more time to work on all these aspects.
Perfect. Thank you, Andrea. I don't see any more questions from the audience, but I would ask both Andrea and Megnaa if you want to just quickly go through the last points that you made, so that we can move to the wrap up and the conclusion of the webinar.
Andrea, do you want to
Yes.
kick yours?
Thank you, Megnaa. So yeah, no, just very briefly to summarize, I think here I was making a point that we need, of course, predictions and a kind of intelligence that also here recalls the artificial intelligence wave, I would call it, of these recent years. And here, of course, we can leverage on machine learning and the power of new algorithms to improve predictions, and also especially to tailor the data and model outputs to user needs, as I was mentioning in my example. And so here the key is to to understand first user needs, and then to transform these into, again, simple metrics that can be used then to drive the machine learning enhancements, for example, as an objective function to optimize. And this, of course, this is just a part of all the work we need, because we need work on all the chain that I described earlier. So more skillful forecasts, more skillful and accurate projections, but also more link with the inundation and assessment of the inundation with impacts, for example, to understand how good our flood extent estimates to inform early action. And then a last point is that we can probably integrate interdisciplinary views with, even if with some limitation in this way I was suggesting in the presentation, by considering more and more action-based criteria, or let's say user-oriented criteria for both model evaluation, but also model development, calibration, and development efforts.
I know we're over time, so I'll just be very, very quick, and you have the slides there if you want to go over it. But as I've said, I think the need from an anthropological or a social science perspective is to foreground local communities, their knowledge, their perspectives, their histories with flooding, and the communities that have been living alongside floods. Often they haven't been resisting floods, but know how to cope with floods already. So that knowledge needs to be captured, or at least understood. We need to understand power dynamics, like the question that came up in the chat box, between communities, within communities, and power dynamics of governance and local level, because the best policy or the best models often aren't implemented on the ground because of roadblocks within communities. And so that's something that anthropologists and historians and social scientists can understand. And the last one is that, one has to disaggregate flood and disaggregate community. There is no one kind of flood. There is no one kind of water. There's saline water, there's fresh water, there's, community means a whole host of things. There's a lot of infighting in communities. And so anthropology allows us to disaggregate each of these. A seawall is not just one kind of seawall or an embankment. Some are beneficial, some are not. And different members based on age, caste, class, gender, religion, disability cope differently. So those differences, I know there are many differences, and that's what anthropology does. And as Andrea pointed out, we're not very good at scalability. But yes, so our job is to build up the complexity, and Andrea can hopefully reduce it for us and create some projections that and together hopefully we can work towards more resilient coastlines. So I will end with that. Thank you, Sarah.
Thank you, Megnaa and Andrea, once more. It was an absolute pleasure to work with the both of you and see, we met before and we discussed together, Megnaa and Andrea discussed together their approaches and their perspectives, and it was a privilege to see this dialogue unfolding, and I'm really happy to have it presented today. If it's okay with both Megnaa and Andrea, I know that we have each other's perspective on each other's context, I would leave it to this for today, and we can think of maybe like disseminated this presentation and the last questions that you have for each other on our website and our channels, if that's okay with you. I will just then proceed with saying that if you want to have access to this presentation together with the recording of this webinar, we have a dedicated event page on our website for this webinar. We will upload everything in there. So if you want to have an easy access, you can scan this QR code or follow this URL so that you get to the dedicated page and you find all the information there. Also, just very briefly, we have a couple of open positions at the DCC. Just want to remind to you, if you haven't had a chance to see it on our website, that we're looking for a program manager as well as a research fellow to help us with the teaching modules that we want to develop for a course on resilient coastal business models. As you see, the deadline for the program manager position is approaching, so please, if you're interested, submit it by November 20th, so a little more than a week for now. Whereas for the research fellow position, there is a little bit more time. You have until November 30th. Again, if you want to see more and you want to have deeper access to these positions, feel free to scan the QR code or see, as I said, this presentation will be made available also on our website. Lastly, also just to tell you, we have many ways to get in touch with you. Just see on our website all the ways you can engage with us. Consider subscribing to our newsletter and watch the recording of this webinar if you want on our YouTube channel. I would think with 10 minutes over time, I think we can conclude this last of this series of webinars, which will come back in 2024. So also stay tuned for that. Once again, thank you, Andrea, and thank you, Megnaa, for this wonderful presentations and for this wonderful discussions that we had. I hope also our listeners and who's connected was able to see the value of this true dialogue. And I'm really happy, and I hope we'll get the chance to work again together and see you maybe on another webinar.
Thank you, Sarah. Thank you, Andrea. Bye-bye.
Thank you, everyone.